This lesson is on absolute value inequalities. In my previous lesson, we looked at absolute value equations and attempted to solve them using number line geometry and distance. I attempted to avoid algebra as much as I could. With absolute value inequalities, I'm going to use the same approach. Remember that the absolute value of x minus c, where c is a real number on the number line, is the distance between x, and x is another number on the number line, and c. So x minus c finds how far x and c are apart, and when you absolute value it, it ensures that you get a non-negative number because distance can't be negative. Let's look at an example. Absolute value of x minus 2 less or equal than 5. I'm going to go straight to the number line and without any rules try to solve this. So let's say we are in the one-dimensional world, and 2 here, we can think of it as, again, the center, and I did state that in my previous video. Now imagine you are ordering pizza from a pizza place, and think of it as a street. Their location is at 2 on this street, and they deliver within 5 miles of the pizza place. Meaning that from this 2, you can go over by 5 and go under by 5. As long as you are within this interval, they will deliver to you. Otherwise, they will not. So let's interpret before working with the number line. This reads as the distance between x, and remember that here x is your unknown and 2 is less or equal than 5. Now let's look at it on the number line. Here we are at 2, the center, and x is on the number line. Wherever this x is, the distance between that x and 2 cannot be more than 5, which means that I can go over by 5 units. 1, 2, 3, 4, 5. This number is obtained by taking 2 and adding 5 to it. That results in 7. We get one of the endpoints. We can go to the left by 5 units. Now I can put the numbers on the number line. Or just subtract 5 from 2. So this boundary or endpoint is 2 minus 5, which results in the boundary of 3. And that is another endpoint or boundary. Okay, so the example of the pizza place, they're delivering within 5 miles of 2. You go over by 5, you hit the boundary of 7. You go below by 5, you hit the boundary of, that should be a negative 3. Those happen to be the solution's end point. So your x's are all the numbers that are between negative 3 and 7. We are looking at all of these values to be a part of your solution. We write the solution as x between and including -3 and 7. This is the inequality notation. All of these numbers, x are greater than or equal to 3, as you see, and at the same time less or equal than 7. So this is the solution in inequality notation, or you can write the solution in interval notation, open bracket, -3 to 7. In general, if we have absolute value of x minus c less or equal than a, we can think of this as the distance between x and c is less or equal than a. Then, going on the number line, we first locate the center. Since we want the distance between our x and c should be no more than a, then we are allowed to go over by a distance of a. Therefore, this is c plus a, and we can go to the left by the same distance to get the other endpoint or boundary. This is c minus a. The solution is going to be every x from c minus a to c plus a. If you have this absolute value inequality, you can rewrite it algebraically as x being between and including c minus a and c plus a. Or you can write this as the interval c minus a, c plus a. Now please keep in mind that if a itself was not included, then we use parentheses for those boundaries. In that case, everything in between would only be the solution. Let's go back to our example. Let's look at this absolute value inequality one more time. We wanted the distance between x and 2 to be less than 5. What numbers have distance from 2 that's less than 5? 3 is one of them, because the distance between 3 and 2 is 1, and 1 is less than 5. Let's choose another number. Let's say we choose -1. The distance between -1 and 2, if you count it, is 3. And 3 is in fact less or equal than 5. Let's look at another inequality. Let's think about this. Here we have x plus 4 inside the absolute values, so that does not directly interpret as distance between a and b is absolute value of a minus b, but here we have a plus. We're going to have to rewrite this. We could write this as absolute value of x, make the plus a double negative, x plus -4. Now we know what the center is. The center is -4 less than 3. So we go on to our number line, locate the center of negative 4. Since the distance is less than 3, we are allowed to go over and under by 3 units to get to the boundaries. One of the boundaries is going to be right there. It is going to be negative 4. We've added 3, and that gives us negative 1. The left boundary is negative 4. We have gone to the left by 3. That gives us negative 7. Those are, in fact, the solution's boundaries. Since 3 itself is not included, we have to use parentheses instead of bracket. Parentheses mean exclusion. The solution is all numbers between negative 7 and negative 1. In inequality form, you can say x is between, double inequality means between negative 7 and negative 1, or you can write it in interval notation as parentheses negative 7 to 1. Okay. Any number between negative 7 and negative 1 plugged into this inequality will make it true. For instance, if I take 0 plus 4, absolute value of 4 is 4, and 4 is in fact less than 3. Another number, let's say we take negative 5. If you plug negative 5 in, absolute value of negative 5 plus 4, that's equal to absolute value of negative 1. Absolute value of negative 1 is 1, and 1 is in fact less than 3. Now let's look at a more than or at least case. Again, this reads as the distance between x and 1 is more than 3. Let's look at it on the number line. Our center is 1. We're going to go over by a distance of 3 and under from 1 by a distance of 3. And that will get us to the boundaries of 1 plus 3, which is 4, and 1 minus 3, which is negative 2. These are the boundaries, but the inequality says that wherever x is, the distance between x and 1 should be more than 3. So say we are within this interval and I take a number such as 2. The distance between 2 and 1 is 1, and 1 is not going to be greater than 3. So our x's are not going to be within this interval. They're going to be outside of the interval. Therefore, the solution would be every number more than 4 and every number less than negative 2. We can write the solution in inequality form. So for the first interval, it is x less than the boundary itself. Negative 2 is not included, so it's just less than negative 2. Or x could be more than 4. X more than 4 is this interval. We can write this in interval notation as negative infinity to negative 2. Well, if you look at the first interval, this interval starts at negative infinity and goes up to -2, united with, or means union, x greater than 4 means that we're going to start at 4 and go to infinity. Let's write down the general rule. If we have absolute value of x minus c greater than, it could be greater than or greater or equal than some number a. On the number line, we locate the center C and go over by a, under by a, to get us a C plus a and C minus a. Since we want the distance to be more than a, then x is not allowed to be in this interval. It is outside of the interval. Therefore, the solution is from c plus a to infinity, or here, from -infinity to c minus a. If we have exclusion, we do not have the equal sign, then we must use parentheses. Therefore, we can translate this inequality to x being less than c minus a, or x being greater than c plus a. In interval notation, it's -infinity to c minus a. That's a representation of this interval in interval notation. Union, for this interval, we're starting at c plus a and going to infinity. So from c plus a to infinity, and you always use parentheses for infinities. And once again, keep in mind that if we have inclusion, then we replace parentheses with brackets. We include the equal sign, and for the interval form, we use brackets for the boundary points. Let me end with another example that I'm just going to randomly make up. So this is not an absolute value equation in previous formats. What we want to do is we want to have an inequality where on the left hand side we have the absolute value expression, and on the right hand side we have the constant. We're going to subtract 2 from both sides of this inequality to get -3 times the absolute value of x plus 2 less or equal than 9. We haven't yet gotten the absolute value by itself. There's a -3 in front, so you can divide both sides by -3. And that's going to give us absolute value of x plus 2. One of the rules of inequalities is that whenever you're dividing or multiplying both sides by a negative value, the direction of the inequality is going to switch. So this is going to go from less or equal than to greater or equal than. 9 over -3 is -3. Let's identify the center. We can write this as x minus -2. We have the distance between x and -2 greater than or equal to -3. I don't have to do much. The solution to this inequality is obvious. Let's translate this. Think about it. distance is a non-negative measure. This inequality says that this non-negative quantity is greater than a negative number. This statement is always true. Something that's non-negative is larger than negative. What is an example of a non-negative number? Let's take 0, for instance. 0 is non-negative. Imagine this is 0. 0 is greater or equal than -3. That checks out. Imagine another non-negative value for this absolute value. Let's say 10. 10 is in fact greater than -3. So no matter what x is, you're always going to get a correct statement, meaning that the solution to this inequality is all real numbers, or x could be from -infinity to infinity.